Hi, welcome. This is a recording of our presentation. If you go to the next slide, we're going to talk about this challenging problem we are facing across our industry. And this is the challenge with hard-coded credentials. Many software developers put their account name and passwords to important parts of the program in the code, in the source code, and you'll find hackers can get to it. So we're going to talk about this in 4 ways. First one is we're going to give a problem statement. Why is this a big problem? And it's as simple as having keys to your house in the software, right? So that's the main problem statement. We're going to talk to you about why is this important and difficult. We're going to talk about why current solutions are incomplete. And so what can we do about it? Next slide. I'm not going to spend too much time on this literature survey. I'm going to provide the references in the back and the end of the presentation and in the YouTube description section. I just want to mention Bill Markey did a Bill McCarthy he did a great job at DEF CON. He uncovered 15,000 hard-coded secrets and he found 66,000 vulnerable sites. And I'm telling you, this is just the tip of the iceberg. And so this is going to be a very important problem. And so the next slide, we are finding more and more that there's malware available and their job is nothing but to steal millions and millions of credentials from web browsers, other software, pirated software, etc. And the Snowflake customers, the one that recently affected them, that was primarily related to compromised credentials. Next slide. So I'm going to hand it over to Ethan Wilder. Ethan Wilder is an amazing expert. He not only understands the technical part of the problem, but he's amazing at presenting this to CISOs. He's working with different teams, working with different departments, and then training the developers to make sure this problem doesn't happen. On to you, Ethan.
All right, thanks, Sudesh. All right, so as Sudesh was saying, I have a bit of a software development background. I did this, I was developing software for about 10 or so years, switched over to security and kind of been working in the product app security space ever since. And so this problem is kind of near and dear to my heart here. And while I will say that my current place of employment has not experienced a breach relating to this, I do have experience with a let's say an unauthorized actor getting access to many repositories that happen to have a plethora of credentials and shenanigans ensuing from that point on. And my experience in dealing with that particular situation and subsequently the massive remediation that resulted afterwards really was pretty eye-opening and kind of changed my opinion on this whole topic overall. This is one of those things that, for example, if this was a presentation at Black Hat or DEF CON, right? You go into these presentations and the speaker will pull up a terminal. They'll type in, who am I? And it shows that they're, a normal user or something. Then they'll type in some magical, mysterious, esoteric command that nobody understands, or they'll run some magical executable process, something that does magical work, things of wizards. And mythical spirits. They'll hit the enter button, the screen will flash, and then they'll do another who am I, and ta-da, they're root. And the whole conference room, 500 to 1,000 people, standing ovation right there. Ah, you did a thing, you are Yoda, that's kind of how things are viewed in the industry today. If I were to do the same thing in this presentation, if I were to pull up a terminal, and if I were to then log into a server as root using the username and password, I don't think I'd get a standing ovation for that. And yet, it would have the same outcome. I'm not supposed to have access to that particular system in the way that I do. In the same way that the guy who used magical powers to gain privilege, privilege escalation and get that access. The outcome is the same. And I can tell you right now, our business stakeholders don't care about the complexity and the magicalness and the amazingness of the vulnerability. They don't care about the vulnerability. They don't care if it's a sexy vulnerability or not. The outcome's the same. You have an unauthorized party accessing something they shouldn't have access to, and damage and shenanigans can ensue from that. That's what matters. And we do have to pay attention to this problem, the same that we have to pay attention to every other problem. And I don't think today, based on my experience and looking around at the industry and talking to other folks who do this and having gone through the cleanup myself, I don't think we treat it the same. I don't. I think we look at it and say, well, yeah, they got keys to the house. Psh, don't keep your key under the mat, right? Just don't do that. What's wrong with you guys? And it's a second class citizen in terms of a vulnerability, and yet the same damage can happen. And this is arguably easier to do. And I think we have to take that seriously. So let's talk a little bit more about what the actual problem is here, what we really mean by the use of hard-coded credentials, okay? Credentials, passwords, secrets, secret keys, things like that. What happens is these passwords, they end up inside of source code. And this is pretty normal. If you're building an application, your application, let's say like it's a web application, your web application probably has a database or some downstream system that it's dependent on, maybe some external service that it's dependent on. That's the world today with microservices and interconnectivity, APIs and the like. So there's always in order for your application to have access to that downstream dependency, there's got to be a credential floating around somewhere. It's got to have access to that thing somehow, because you don't just allow anybody to log into your database, right? There's a username, there's a password, could be a multi-tenant system, et cetera. So these things have to be there, and the application has to have access, and so we have to somehow give this credential to the application itself. This is usually the first problem that we run into when we talk about remediation. Why do we have passwords at all? I've heard CISOs say that, and well, it's because you have to actually do the login, right? So you got to get them there somehow. Um, and what generally tends to happen is that the developers will throw it in a config file. For example, there's two screenshots here. One is kind of the Java standard way of doing this. One's a .NET standard way of doing this. You'll have your connection string to your database, and there's your username and password right there. And this gets stuffed right into the configuration file, gets committed and pushed right into your source code repository, and it's there and it's versioned. And once it's there, once it's in your history, I mean, that's the primary use case of a version control system. That's what they're designed to do. They are designed to never forget what you put in there. That's why we use them. And so likewise, if we stick a credential in there, it's very difficult to get it out and very doable to find. And so now we have credential leakage inside of these systems. Now, why do we do this? Why does this happen at all? And the fundamental reason, ultimately, I'm just going to say it, we are taught to do it that way. We are. As a programmer, I'm guilty of doing this at one point. Absolutely. I posted some screenshots here. These are from straight up tutorials you can find online. For example, if you wanted to learn how in PHP to connect to a database, you'll go find a tutorial and there will be sample code. And that sample code will show you the functions to use. It shows you how to handle the errors. And right there at the top, usually, are a few variables with your username, password, just right there in code. And the reason I don't even fault the tutorial users or the tutorial writers for doing it this way, because credential management is difficult. If they actually spent time to set up an entire Vault instance and explaining that to a new developer, their tutorial wouldn't really be a how do I use a database in PHP tutorial. Their tutorial would become how do I do credential management in PHP? And oh, by the way, at the very, very end, the last 10 seconds of a 20-hour tutorial is going to show you how to connect to a database. It's complicated. There's substantially more code involved in proper credential management than there is in what the tutorial is trying to accomplish. And so the tutorials, they don't have them. You don't do that sort of stuff when you're learning how to code. It's too complicated for new developers. So instead, we showed new developers to do it this way. This is what they use. And it should be no surprise if your developers, even the seasoned ones, if they're experimenting with a new AWS service or new Azure service even, they will usually go Google a tutorial, how to do it, find some sample code, copy and paste that sucker right into the source code, right in the repository. Can't tell you how many times I've done a security code review and looking through code, and I could just see it, copy and paste it directly in tutorial code right there, straight off the site, comments and everything. Sometimes the copyright copied right in there. And so this habit is something that we just naturally teach people to do. Likewise, in these README files, right? You'll have the default username passwords is right there in the README files, et cetera, et cetera. It's just what we tell people to do. It's what we show them how to do, and that's as a result of that, people will do what they're taught. And so it's one thing to tell users to train and do better, but we all know how that works, right? Like it's it's not something that you can just slap somebody on the hand and say, nah, do better. There's always new developers coming in. There's always new contractors coming in. And it's a constantly churning thing. And until the industry really gets better at credential management, this is going to be a problem, really. Because again, it's how we teach people to do it. And unless we have an easier way of doing it, it's just going to keep happening, keep happening. So in this presentation, I also, you're fortunate that you get to learn how to hack every single Fortune 500 company in existence today in 5 easy steps. Very, very straightforward. Step 1, you get on Glassdoor, you get on LinkedIn, and you find developers. And that's not terribly difficult. So some companies, not even software companies, they will have hundreds to thousands of them. You find them and you fish them, right? You fish them. And oh, Ethan, that's not a very fancy kill chain there. It's not a very fancy attack vector. Nope, it's not. But we all know it happens, and we all know it can happen. We've all seen those phishing click rates. I'm sure your company, it's one of the things that all the companies report on. What's our click rate? How many of our employees have clicked on the phishing emails? And it's never going to zero. It's never doing that. You're pretty good if you get it down to a fairly low percentage. That's a pat on the back. So with a few thousand developers and some really well-crafted phishing emails, you're going to be successful at 1 and 2 eventually, right? Once you phish them, well, you get access to their GitHub, their Bitbucket, their Azure DevOps, whatever they're using, you get access to that source code repository. And then what you do is you open up the search function and you type in password. You hit enter. That's it. You're done. Game over. Because naturally, there's going to be a hardcoded credential in there somewhere, and that's going to give you access to something, and then you just keep going from there, and it's all over. It's really that simple. No one likes to talk about it, but it's really that simple. I'll give you a second scenario about how this is constantly happening, and I'm sure everybody in here maybe has 1 or 2 of these experiences in their past. But let's say there's Carl. Carl's the contractor, and his contract's expiring in 2 weeks. Now, Carl, he's a good guy, really solid developer. And he built this really fancy, elegant library during his time at your company. And you know what? Man, he really wants to just, keep it. He wants to use it at some point. Maybe he won't copy and paste it into the next code base, but he's really proud of it. He put his blood, sweat, and tears in that thing. He really wants to use that pattern again. So, he's just gonna keep it, just gonna do it. And he'll upload as a result of that. He'll usually let's do like a git clone or something. Basically, upload the entire application code base, which includes his library to his own personal GitHub account. And let's say he doesn't open source it right away, but let's say he's going to modify it. He's going to change it. He's going to make it more generic. It's going to make it look like he didn't build it at your company and then decide to keep it. He'll modify it and he'll produce something new, and then he open sources that new thing that he built on top of it. Now, this new thing, it may not have any of your company's information in it on the most recent commit, but the thing is that it does in history. It does in the Git history, because again, that's what these version control systems are designed to do. They never forget what you put in them to begin with. That's their whole purpose. And so if this happens, which, come on, be honest, this has happened a number of times. If this happens, all of your intellectual property for your your company not only just got leaked, but all the credentials that happen to be inside of it also got leaked, which is a much more magnifying problem. It becomes a much bigger problem when there's actual information there, including database addresses potentially, or external service addresses, the usernames, the passwords to those things. It's right there. Easy way to access that stuff. So it happens, guys. It happens. This is a thing. Sudesh already mentioned this has happened before. Just searching hacker steals credentials Git. Just run that in Google. I mean, it just pops up all the time. Stolen GitHub credentials used to push fake Dependabot stuff. I mean, there's all sorts of things you can do when you get in there. And then there's even tutorials out there on how to search GitHub for like .config files to find things. It's a thing, and this is going to be continue to be a thing. Hackers who've been developers, they know this. They know how this works. Again, it's not sexy. It's not an amazing vulnerability. You're not going to get that standing ovation. But somebody who wants to make a lot of money by stealing all of your data doesn't care. They really don't. And we need to really kind of respect that fact. So, okay, that's the problem. What do we do about it, right? What do we do about it? Well, let's take a look at the industry. What does the industry do here? There's a few different ways people approach this problem. Static analysis, built-in stuff, open source, closed source, yada yada. So let's talk about this here. Let's see what's actually out there in the industry. And I'm going to accuse a lot of people of doing checkbox security on this. Okay, I'm just going to give you that as a little primer there, a little, brace yourself of what's incoming. Not everybody, okay, not everybody does this, but it's a thing. It's a thing. So let's talk about static analysis. All right, what is static analysis? Well, this is your Veracode. This is your Fortify. This is the scanner that will scan the source code as it is in static form. Sometimes it actually scans the artifact binaries and not the actual source code. Some of them do scan source code, but this is kind of the first place that people go with how to detect these things. And there are rules. Don't get me wrong. There are rules inside of these systems like Fortify and Veracode and yada yada. There are rules in there that are designed to find when people hard code credentials. So it does happen and it does work. But the problem is it only works sometimes. You see, remember the two examples that I showed you about the configuration files? Well, static analysis doesn't actually scan your config files, it scans the source code itself. And not only that, it actually scans like a kind of an intermediate compiled version of the source code itself. It doesn't even scan the raw source code really most of the time. So it's not going to find, quite frankly, a lot of them, the majority of places where this actually happens. And I've seen it a number of times where your app security person says, "Do you scan hard-coded credentials?" They'll ask their partner, Veracode, Coverity, AppScan. They'll ask them, "Do you guys do that?" And they say, "Yeah." And that's a true statement. And then they go back and tell their CISO, yeah, we scan it, we're good. And CISO says, okay, we got this covered. Don't have to worry about it ever again. But that's not the whole truth, right? It's not actually covering much at all. You got to watch out for that. That's a thing that happens a lot. We have to be honest about what's going on here. The next option here is the built-in scanning systems that are present in GitHub, GitLab, Azure DevOps. Fortunately, the repository systems are starting to have some of this built into their underlying systems, which is great. Honestly, this is a great place to do it at, and they're in the perfect position to stop it. And again, this is where we can easily say, oh my God, do you guys scan this stuff? And GitHub going to come back and say, yeah, we got it. We have a function there that'll allow you to scan credentials. It'll alert you to it. It's great. It's amazing. And we say, okay, we're covered. Well, here's the problem, guys. It doesn't really cover everything again. If you look close, they cover things like AWS keys, Azure tokens, Google tokens, things that are structured. Okay, structured, because really what they're doing underneath the hood is they're doing a regex scan, honestly. And regexes, as we know, are not really not that great. They're great at finding structured patterns, but when you have variable use cases where password equals how things are written inside of English, there's a lot of variance. Regexes, they start to pop a lot of false positives, and these underlying platforms, like these source code platforms, they don't really like false positives because that impedes the developer experience. That goes against what they do. And it's kind of that underlying philosophy there. And so as a result, they usually don't go for that sort of stuff. So you got to be careful with these. Now, I will say this is getting better, but I'm also going to say it's still, as of today, it is not enterprise ready. I mean, there are still systems where they can have some more advanced protection mechanisms in place, but they'll still pop up like a window to the developer. It says, yeah, you got a credential in here. Um, select your option of what you want to do. And one of the options, no joke, says, I'll fix it later. And the developer just clicks that button and that's it. It's done, gone, just goes right through. And of course, the fix it later, right? Right. We all, yeah. They don't immediately forget after they click the button. Not at all. Now, not all developers, but let's be real. It happens. And it's kind of this underlying philosophy again that the development experience is more important than security. And in fairness, a lot of times that can be true. It really can be, depending on what you're really talking about. Sometimes you do need to push out fast. You do need to, and sometimes it's appropriate to fix it later. Absolutely. But sometimes it's not. Okay. There are situations, there are use cases where no, we really do have to care about this and we have to care about it right now, and it's worth stopping and fixing. But those use cases are not really present still at the moment. Other situations that you'll run into with the existing platforms, fail open. So let's say you have a credential inside of your source code and you push up a lot of source code at once. Maybe you're uploading an entire code base. Maybe you're migrating it from somewhere else, like you just inherited a large code base from somebody that you bought, and you're doing an acquisition or something, and you upload that, and there could be credentials all over the place in it. If it takes longer than 2 seconds to scan, well, nope, done. It just fails immediately, and it fails open. It just lets it through, no notification, nothing like that. Or they do like a max of like 5 credentials per pull request or something along these lines. Again, it's, what's the likelihood of getting more than 5 credentials per pull request? It's like, well, if you are doing small amounts of coding and per commit, you're probably in a good spot here. But again, if you're doing mass migrations, you're going to miss everything, honestly. And these aren't really at the forefront of stuff. We're very, very much approaching this problem from that standpoint of do we check the box? Do we have something that solves this problem for me so I don't have to think about it? And we don't look under the hood. When you look under the hood, it's scary. Scary what you find. So it's moving. The market and the industry and these platforms are moving in the right direction. That's good news, but they are not there yet. There's still work to be done. The open source space has made some progress in this. My teams actually have produced a tool that will actively stop new credentials from entering repositories. We actually built this in 2018 in response to a need where we saw developers continuously doing this, even though we've been training them and telling them not to. We connected right to these things called pre-receive hooks, which are built right into Git, not GitHub, not GitLab, not the Git platforms, but Git itself actually has these hooks that you can connect to. And we run a scan right inside of there. We published how we do this in this project called Sedated along with OWASP. This is out there for everybody to look at and completely free. And we also have names and stuff, and you can ping me on the side if you want to know how we actually implemented this. We built a whole metric system that measures how we do with it. We're actually running at 3% false positive. It's been very, very successful. This tool, however, it does not detect secrets though that have already been committed into your code base. Still a bit of a problem. There are some tools that out there that do that in the open source space, like GitRob, Trufflehog. Trufflehog, I think, is the big brand name that's out there. It's all these tools, they are basically running on regex scans. That's basically what they do, and that is fundamentally their problem for a number of reasons. And I'll actually talk about a couple of them here in a second, but everything that you find on the market today is all regex. Okay, that's how everybody's solving this problem. And there are limitations to that we're going to talk through. Okay. Um, so after facing this particular problem for real, and specifically the human beings that are responsible for doing it, okay, because we are dealing with humans, we're not dealing with robots, we're not dealing with an automated crawler that finds credentials or something. We're dealing with people who are digging and intentionally looking for privilege escalation points. So when we consider that particular threat vector, I ask myself, what do we got to do here? What if I was going to tackle this? What do I actually need, right? Well, first off, I need something faster than the regex scanners. It's got to be faster. I have some experience again with these regex scanners, and the POCs are great when you have 5 to 10 regexes, but when you start getting the amount that you really need to really cover everything, you're in the 50 to 100 range, and they're complex regexes, and you're dealing with tens of thousands of repositories. Some of them have millions of lines of code that have been around for 20 years. And if you need to scan this stuff regularly, or even just once, it'll take days, just days, and that doesn't work. We got to do something faster. Um, we also, and I'll talk about this problem next year, but how we're doing the scanning has to change as well too. So yeah, we definitely need something that's based off of regex, but we needed something that's going to be developer friendly reporting, and it'll show all of the historical locations of a secret. Okay, your code base is it's a giant web of interconnected stuff, basically, and it's prone to changing. And you really got to show everything where it's all at, because you don't want to show some of it to a developer, have the developer fix some of it, and have to come back later and fix more. That's no fun. It's no fun at all. Um, things happen. Things happen here. So let me talk a little bit about what I mean here. Okay. So Git itself, I'll talk a little bit about the internals of Git. It doesn't actually store diffs. So I posted a screenshot of what I mean by this. If you look through a Git repository history, you're going to see these diffs. They'll have a little red of what line got changed. It got basically this got removed, and then the green is this is what got added to it. It's a diff, and we very easily think that, oh, well, that's how it actually stores everything, and that's actually not the case. These diffs are dynamically generated when you go look at history. What it actually stores is the actual files themselves. It's underneath it. You at each individual commit, you can check out back to like what you did 10 years ago inside the code base, and when you rewind your workspace 10 years back, it'll look exactly like it did. All of the files will be present the way that they were back then with all the text back then. That's kind of key here, okay? Because when you look at that commit inside of your Git history using the Git tools, you'll see the diff between now and then, what's actually changed. You won't actually see everything that's in there. So this becomes a problem with credentials, because if I enter a credential in July, okay, and that credential is then present in every single commit from July until today. Okay, it's present all the time. Yet in your Git history, you will only actually see it in your Git history when it got added or potentially changed, if it got added or changed. And so that gives the false impression that, well, that commit, that password doesn't actually exist in any of the commits in between. And so if I'm going to go remediate this thing, I'm going to go back to July when I first added it, and I'm going to go fix it there. And you can fix it there. What happens is that your scanner will then scan all the diffs, and it'll find it in the very next commit, the one on, let's say, July 15th. Okay, great. Well, you got to fix it there. Well, then it'll show up in the very next commit, August 1st. You end up playing this game of chase the commit. And after about 2 or 3 of these, your developers will be chasing you down the road with pitchforks. It is not a good experience. I've been there. That's actually happened. It's actually happened. So no. We need to show where this thing is actually at everywhere inside inside the repository. What branches it's on inside the repository is another thing. Okay. Um, because your code base, you could be working on a release that's maybe it's the December release, and then there's another release in February. So you could have people working on the stuff in February and the stuff in December, and as they're merging and keeping things up to date and doing things, it's very, very dynamic in how it changes inside of there. And sometimes these releases, they get abandoned and they never actually make it back to your mainline branch of what's in production. A lot of times it's very easy. Like when we're talking about app vulnerabilities, we think what's on the master branch, that's the only thing that matters because that's what's in production. I don't care about production when we're talking about credentials and source code. None of that matters. I care about the credential itself. So if there's an orphan branch over here, if there's an orphaned pull request over here that has a credential, that's in your repository. and that's discoverable, and you can find it. I don't care if it got deployed or not. None of that matters. It's there. You can find it. You got to show these things. You got to dig this stuff out and show people where it's at so it can get fixed. So we got to be able to find everything that's in there. Hopefully, I'm making some sense with how this works. So I sat down and I wrote a tool. And I was like, you know what? This can't be super hard. Let's just play with stuff. Okay. After about 2 or 3 weeks, put something together here. And you're seeing me run it. Yes, it's a Java jar. Again, I was just kind of playing with something. And it turns out this is pretty reasonable to do, to be honest. And the state of the industry really, unfortunately, forces us into doing this. Those who I've talked to who've really solved this problem already, they've done some level of customization and some sort of custom building for these things. So like what you're seeing this thing do here is it's actually, again, it's not scanning the diffs inside source code. It's actually going through every single commit and scanning through every single um, essentially object inside of the repository, which effectively is all the files that are inside the repository. This same repository, I'm scanning WebGoat here. This same repository, when I scanned it with TruffleHog, takes about 20 to 30 minutes, depending on your computer and what's going on. And this thing is going to finish in about 45 seconds. Should polish off here pretty quickly with what's going on. Yep, there it is. There it is. Total time 43 seconds. And I just dumped out the file. So let's actually take a look at what I found. It doesn't do regex scanning. It actually kind of invented a new way of scanning, slightly based off of regex, but we don't need the complexity that regexes have, which is involving a lot of the look back logic. As long as your code can understand syntax and configuration syntax, that simplifies the pattern matching process. And then you start looking and scanning things differently than just scanning diffs. And now you're not scanning dynamic stuff that might change whenever a developer rebases their source code repository, which will change your entire history. All that goes away. You're actually scanning the meat of what's inside of it using non-regex stuff. So let's take a look here at what this thing has. Pull that up, pull this up. All right, so yeah, this is kind of an example, and this is actually a pretty good use case of showing just how varied this can really get. Again, this is WebGoat. Okay, this is WebGoat, which isn't really even a great place to find this stuff, but there's a surprising amount of hardcoded credentials in here. And in there, we can see there's a secret sitting inside of a JSON file. You'll see them inside of, this is actually a doc, believe it or not. This is a build doc, and it's in XML form, right? You got your attribute name, and you got your value in here. You got your input forms, default credentials that are just set on your input forms. Of course, you got your standard Java variables, password Dave. Down here, you got a password that's passed as a hard-coded string right into a function. It's everywhere. And again, what we do here is we show the history, where it's actually at, all the commits that it's at, and all of the branches that it's discoverable at. And you can see just by looking at this, these credentials, once it's inside of here, it almost explodes in its discoverability all over the place. This one commit, it's on all of these different branches. And so just deleting, like maybe I say, if we report and say, you know what, this branch right here, this ref, this right here, this has the commit, that's where the credential is. Developer's probably going to go in here and just delete the branch. Well, great. It's still on this one, and it's on this one, and it's on all of these over here. When you make a pull request into GitHub, believe it or not, you're actually creating a ref that lives only in your remote repositories. And if that pull request, even if it's rejected, that pull request still lives in history. It's still there. It's kind of a scary thought about how anything you put in here really, really saves itself. And so it's in here. Now, sometimes these files will actually change depending where you go, because again, the history itself actually changes. And it's really pervasive, and sometimes these things can be elusive. Now, TruffleHog also, it'll find the commits, but it's not going to show you this. It's not going to show you the branches. It sometimes will show you the files, but it's just not. It's almost there, but not all the way. And I have yet to find anybody who's really honestly doing this, where they're really interrogating your Git history and showing you where everything's at and how you need to fix it for real. Show me everything. Don't show me a piece of it. Show me everything. because I need to remediate that. I need to be honest about how we're remediating it. Like, let's not pretend that the problem is smaller than it is. If it's a big problem, yeah, that's scary and it sucks, but we have to admit it's a problem, and then we can address it responsibly. Okay. And so let's actually talk about that. Whoops, I triggered it again. There we go. So what do we do here, right? Let's say you're impacted by this and you're starting to realize, yeah, this is a thing. So what do we do? Okay, first thing you got to do, okay, you have to care. You have to care about this problem. We got to get out of the habit of, because it's not a sexy vulnerability, it's not some esoteric knowledge, it's not done by Yoda. Yes, your 12-year-old can do this. Your 12-year-old can log into a SQL database with the username and password. We have to really understand and care about that fact that is a problem. And again, we're dealing with human beings who are looking for credentials. We're not dealing with bots. We're not dealing with automated stuff here. We're dealing with people that are scouring Git repositories for passwords. They're being creative with how they're searching for it, right? We got to understand that. Again, admit to the problem. Okay, we need to go through some steps of acceptance here. Admit the problem to yourself, right? Step 2 then is do an honest assessment. All right, we got to take a look. That was too fast. We got to take an honest look here. Dig it all out. Let's really deal what we're dealing with. Let's really admit what we're dealing with. This could be very, very massive. Could be very, very small. But let's not lie to ourselves and pretend like it's small when it's big. Let's not do that. There's a work culture and a budget problem, naturally, because again, how do you deal with passwords? What is your company doing with how you deal with passwords? It's one thing. It's very easy to say, well, I have a password management tool. Okay, we have HashiCorp Vault at our company. Okay, how are you using it? Are you using it? Is it easy to use? Because that thing can be really complicated to set up. Are those patterns established yet? Are we kind of committing to being responsible with password management, or is it just, we really got to release it? It doesn't matter that much. It's fine. We got to address the culture. Admitting the problem is a big part of that. And when we have all of this in front of us, now we can start to set up a project. Okay, we can start to set the budget. Get some project managers together, figure out the real resource allocation. And at this point, we're probably realizing, oh my God, this is a big problem, or we have a lot of work to do. Oh, that's going to be such a slog. And it probably is. That's where iteration will come to save us, hopefully, right? We don't maybe have to fix it all right away, but come on, little bit, little by little. All right. Let's talk to those. Let's talk to our senior devs, and let's figure out, some of these repositories probably don't really need to be here anymore. Maybe can we get rid of them? Do we need to change, like just do a massive credential rotation? Would that be easier? Like we can get in here and figure out big steps that we can take to knock out a lot of this with the lowest amount of effort, right? We can manage this like a real project, like we do the other vulnerabilities, right? Like if we treat it like all the other vulnerabilities, we can manage it like all the other vulnerabilities, right? Now the execution process, you're probably going to need a few things. First thing you're going to need is some sort of hunter-seeker software that's actually going to find everything. Okay. Now, again, I mentioned this before. Most people that really attack this problem, they usually have to write something themselves, just because what's out there, it's getting there, but it's just not the whole thing yet. Okay, it's not the whole thing yet. If you're interested in even the thing that I have out here, reach out to us. Let's talk about how you can use that thing potentially. How do we make something like this enterprise ready? Like I'd be happy to share with the stories and the lessons that we've done for this. Okay. So what you got to find everything. So that's the hunter seeker software. The second thing you're going to need is some way to remediate and clean up. All right. There are tools for this as well. It's really nice. There's this BFG repo cleaner tool out there. This was actually recommended by GitHub. I have no idea. It's open source. I have no idea who this guy is that built it, but it's fantastic. It's essentially a find and replace that you can do that'll rewrite your history for you, which sounds really scary, but it works. It actually works pretty well. And again, get with your senior developers, because again, maybe we just delete some of this code. Maybe we don't need that stuff. I've seen developers who have taken the path of just squashing their history, which is a little weird. It's probably not for everybody to do. And what that is they basically wipe out the history and shove it all into one commit, almost like starting over. There's reasons to do that. There's reasons not to do that. I'm not going to get too much into that, but again, talk to your senior developers. They're going to know if that's a viable option. And it might be, because if it is, that's a real quick way to deal with it. Honestly, you fix it and then you squash everything. Real quick way to deal with it. There's options. Okay. So it's not impossible to clean up and remediate. You just have to be targeted about it. And then the last thing that we got to do is remember that even after we clean up, it's not done yet, right? Because developers are always writing new code. You're always getting new developers. They are probably, again, we're teaching people how to do this. This is going to be a perpetual thing, right? So we gotta teach the developers. We have to unlearn them. We have to unlearn what we have learned. In combination, we know that training is never enough, right? We still have to put some kind of protection mechanism in place, a lot like sedated. This is actually one of the more effective ways that we've done it is we rely a lot on training and then like a push protection system that cuts a lot of this out. It's still in there here and there, but it cuts a lot out, and that's pretty effective. But then measure it still. We're always looking for good metrics, right? As information security leaders, how do we communicate the safety and security of our company and of our cybersecurity posture? It's a great opportunity here. How many new credentials are we seeing every day? Do we have to ramp up training, or are we doing a good job? It's a good opportunity to pat everybody on the back if we're doing a good job, right? So measure it, do some metrics, and again, let's treat this like a real thing, like a real problem, because it is a real problem. And if we do that, we will be in a much better place with it. So at this point, I would go back to questions, but since this is a YouTube video, I'm not going to do that. I'll just say that we do have some references. Again, these will be posted. And I'll leave some contact info here, and I'll actually pass it back to Sudesh if you want to finish up with any additional information. Thank you for giving us your time.
Yep. Hey, thanks again, Ethan. Great presentation. And please reach out to us. Put your comments on the YouTube section and reach out to us. Here's my contact information. Please mention credential hunting when you ask for my LinkedIn connections. Just don't send me a blank one. And thank you very much for watching this.